AP Calculus AB, Unit 3, Day 8. So for the warm-up, what I want you guys to try and do is fill in as many of these rules as you can from memory without looking them up. I have U's in here, and that's just really to emphasize the fact that there would probably be some kind of inner function. So your answers will just have U's in them, but the rules are the same. But let's see how many you remember. Try and do as many as you can, and then we'll do them together and you can fill in the rest. But you do need to memorize these. You got to be quick at these. You got to recognize them. And you won't be given any on the AP test. So go ahead, pause the video and try them. All right, so first one is power rule. You bump it up 1, divide by the new exponent plus c. And I'm just putting u's here instead of x's because there's a u here and a du here. N can't equal -1. If it does, that's a different rule. Cosine, be sine, not negative, just positive sine. Derivative sine is positive cosine. Sine is going to be negative cosine. Because derivative cosine is negative sine, we don't want the negative, so we need extra negative to cancel a negative out. Secant squared is tangent. Cosecant squared is negative cotangent. Secant tan is secant. Cosecant cotan is negative cosecant. Plus c, of course. This is not the power rule. The power rule would bump it up 1, divide by the new exponent plus c. Well, that just doesn't even make any sense. This is natural log of the absolute value. You have to have the absolute values plus c. E to the u is e to the u. B to the u is b to the u. The derivative of any base exponent is that times the natural log of the base, but going backwards, we got to divide by the natural log of the base. Plus c. Inverse trig. This is inverse tangent. And this is inverse sine. I guess it could, like I said, be negative cosine inverse, but we usually just stick with inverse sine. That's all you need. So, all right. So one of the big things, I've been talking about this for a couple days now, is a reverse. We still need, we have all these rules, but we don't have reverse product, quotient, or chain. So we're going to focus on chain right now. So reverse chain rule, product and quotient are probably going to fit into the chain. So the chain rule, when you take derivatives, let's just start with that, right? So we're going to do reverse chain rule. It's called U-substitution. But before we do that, let's go ahead and take a derivative using the chain rule to remind ourselves how that works, because it's the same idea but backwards. So the chain rule says, all right, do the outer derivative first, leave the inside the same, right? And then multiply by the derivative of what's inside. Now, this is what we let's go ahead and take the integral of this and kind of see how that works. So if we're going to go backwards now, we should get back to that eventually. And let's see if we can figure out how it works. It should give us x squared plus 3 to the 4th power, okay, plus c, of course. That's what we should get. So let's kind of see if we can kind of figure it out without just saying what it's going to be. So this is there's an inner function, right, involved in this original problem. And so what we usually do for the first step is let u equal the inner function. So if it looks like there's an inner function issue here, we usually go ahead and say, okay, let's just make it u, keep it simple. U equals x squared plus 3. That's going to allow us to focus on the outer rule first, because when we're only, when you do derivatives, you do the derivative of the outside first, then the inside. But when we're undoing it, we have to undo we're going to undo the outside first, and actually, we're going to kind of undo the inside first, right here. So then number 2, we're going to take the derivative of the inner function of u. Okay, so that would be du dx. And the derivative of that with respect to x is 2x. Now what we'll do is we're going to move this dx over here. And in the future, I'm just going to put it over there right away. But I'm going to move this little change in x over here. Okay? So now, when you see 2x dx, we're going to replace that with du. Okay? So now, for u cubed du. Now, if you're going to do this u substitution, we want to change everything that has to do with x to u's, including the dx. Now, this problem is pretty simple to do, right? This is allowing you to focus on the outer derivative now, right? The outer rule, which is a simple power rule. It's 4, bump it up 1, divide by the new exponent, plus c. But we have to get it back into x, back in terms of x, for our final answer. The u thing was just something we made up that we used to help us kind of make it easier to think about. So we're going to replace u with x squared plus 3, probably in parentheses. So that's your final answer. Okay. Now, the fact that we used the chain rule result without really clearing it up made it a little nicer this time. In the future, it's not going to usually be so like perfectly set up. That's fine. You know, it's going to be the same amount of work. It just might not, you know, be like right in your face. As obvious. So we got a few examples on the back of some problems that we've been maybe even doing without u substitution. Like this next one. If we were to try and do this one without u substitution, you'd FOIL this out, which would be horrible, right? I mean, possible, don't want to do it. We want that to be our u, our inner function, okay? And then du is going to equal 2x dx. So what I see here is I see the x and the dx. Usually the derivative of what's inside should be the stuff that's outside, because this should be the result of a chain rule. Now there's no 2, that's fine. We can move the 2 over here. And so the point is, I'm going to put the 1/2 in front, and there's going to be u to the 50 du. Now we can, you know, so this, you know, we just want x dx, okay? So as a result, we get an extra 1/2, and we usually just put it in front, all right? Okay, power rule, u to the 51st, bump it at 1, divide by the new exponent, plus c, of course. Need to get it back into terms of x, so this is going to be 1/102, x squared plus 1 to the 51st power plus c, done. Okay? Now, a lot of times in the future, we'll probably just do a lot of this in our head. And the more you get good at this, the more you'll just see it without even having to write it all down. I'd rewrite this just because I think that's easier for taking derivatives and integrating, but it also makes it really clear that if there is an inner function, it should be sine. And then in your head, you should be already thinking, well, is that going to give me cosine dx? It is. So cosine x dx. I'm putting the dx on the right side right away now. It's over here, and then we move it, but I'm just moving right away. This works perfectly. It's going to be u cubed du. So it's just going to be power rule, bump it up 1, divide by 4, plus c. And then the final answer is going to be sine x to the fourth over 4 plus c. Now, you're never going to see the answer written like this. It's always going to be written like this, which is that kind of lazier way of, more compact way of writing trig to a power. So it'd probably be good to go ahead and write it like that, because you're never going to be choosing that from like a multiple choice list of answers. It's going to look like that. Okay, next one. Well, what's inside should probably be your u, right? And then du, hopefully you see it's 3x squared dx. The 3 doesn't really matter. It's the x squared dx that we need to make sure is there. Don't want the 3. That's an easy fix. We'll just put a 1/3 out in front. Now this is going to be the square root of u du, which is a power function, power rule. So you're going to bump it up 1, divide by the new exponent, multiply by the reciprocal, plus c. You want to rewrite it back in terms of the original variables, x. So replace the u with x cubed plus 1. And did I make a mistake? Let's see. Divide by the new exponent. Oh, this was supposed to be a 3. Somehow it magically became a 2. So this is going to be 2/9. All right. Now, we got to watch out. Most problems I'm going to be giving you, I think all the ones at least in science assignment, are going to work out great. But sometimes the inner function, and you should probably even see it coming, the derivative of this is going to give us isn't going to give us x dx, it's going to give us x squared, which is not good. Okay? This is what some people will try to do. They'd be like, well, can we just divide by 3x so that leaves like an x dx, and we'll just put 1/3x in front like that? No, you cannot do that. No, you can't do that. Okay, you can't just have x's floating around here. Let's see. Now, sometimes there is another option. You could say, okay, well, could I, let's see, if we keep the x inside, that's what you really should do. We could maybe solve for x in terms of u. That'd be x cubed equals u minus 1, and we'll take the cube root of both sides. This might be a way to get around it, but I don't really think we're going to be able to integrate that. So that's not really much better. Still can't do it. Okay. So, can't do this problem. Now, Mr. Statham, my predecessor, used to say, ex-President Bush, George, or, Herbert, was he the first one? They were both from Texas. So he said, don't mess with Texas. Sounds like a bumper sticker if you go to Texas. Texas is very proud of itself. It's big. They say everything's bigger in Texas. Don't mess with Texas. So President Vonderheide, ex-President Statham, would say, don't mess with the X's. Meaning, when you do U-substitution, you shouldn't have any X's in your work. Okay? It should be all U's. Right? You can't just have some random X hanging out there. That's not going to work. All right. Today's assignment, read page 388 to 389. Do problems on 392. Number 1, just parts A and B. Number 2, just parts B and C. Number 3, just parts B and D. Number 4, just part A. Number 5, part A, B, C. 7, 9, 11, 13. They're almost all odds. Check them in the back of the book. And let's see how you do.